Hello everyone and welcome back to the channel, where we simplify complex programming concepts in a friendly, approachable way. Today we are delving into generics and their constraints in C#. Generics are one of the most powerful tools in C#. They make your code reusable, flexible, and type-safe. But with great power comes great responsibility. And that's where constraints come into play. By the end of this video, you will know how to write reusable and reliable code using generics and constraints. So without further ado, let's get started. Imagine you're writing a class to process integers and strings. Without generics, you'll need to write a separate methods or overloads for each type. Looks fine at first, but what happens when you need to handle floats, boolean, or custom types? You'll end up duplicating code for each type. A classic case of bad design, isn't it? With generics, we can write a single method or class that works for any type. Let's rewrite the processor class using generics. Notice how we avoid redundant code while keeping everything type-safe and clean. That's the beauty of generics. While generics are flexible, sometimes you need to restrict what types can be used. For example, what if you want to ensure the type is value type or implements a specific interface? That's where constraints come in. Let's explore the different types of constraints in detail, along with their usage. The struct constraint ensures that the type parameter is a value type, like int, float, or custom struct. This is ideal for scenarios where you're working with numeric types, enums, or other non-nullable structs. The class constraint ensures that the type parameter is a reference type, like a string or custom object. This works perfectly for objects or anything that supports nullability. What if we want to allow nullable types? Easy, just add the question mark to your type constraint. This is great for handling scenarios where a value might or might not exist, like optional parameters or database fields. Let's say you need to create instances of the type parameter. For that, we use the new constraint. The new constraints ensure that T has a parameterless constructor, making it safe to create new instances dynamically. What if you want to enforce that the type implements an interface and satisfies other constraints? No problem. Just combine them, something like this. Here, T must be a reference type, for instance, a class, implement the identity interface, and have a parameterless constructor because of the new keyword. This combination gives you a structured, predictable way to handle generic types. And there you have it, a deep dive into generics and their constraints in C#. Whether it's ensuring type safety, creating flexible method, or structuring reusable classes, constraints make generics incredibly powerful. What's your favorite use case for generics? Let me know in the comments below. If this video helped you, give it a big thumbs up and hit that subscribe button for more programming tutorials. Until next time, keep coding, stay curious, and have a fantastic day. Cheers!